So we're on page 123, and the problems we're going to do are number 10 right here, and we're going to do 14b, this problem right here. We're going to do 15, and we're also going to do 16b. So first problem, number 10, find two positive numbers whose sum is 30 such that their product is a maximum. So we're going to let x equal the first number and then let y equal the second number. The sum of the numbers is 30. So find two positive numbers whose sum is 30, and xy equals the product. So now from equation 1, we can rewrite this as y equals 30 minus x. In other words, transpose this x to the other side. And then what we can do is substituting for the y in this right here, we'll get that the product is x. Instead of y, we're going to write 30 minus x, so we have everything in terms of x. So this is the product is 30x minus x squared. Since the coefficient of x squared is negative here, it's minus 1, less than 0. The parabola is a frown, and there is a maximum value. In other words, the parabola goes up and then down, so it's a frown. And at the top of the frown, there is a maximum value. So now we need to calculate the vertex. The vertex is minus b over 2a. So minus b, this is b right here, the coefficient of x, minus 30. A is minus 1, so 2 times minus 1, so we have 30 over 15. This tells us that the x value is 15. And the y value is 30 minus x, or 30 minus 15, so it also happens to be 15. So the product now is 30 minus x squared, so 30x minus x squared, so 30 times 15 for the x, replacing the x, minus x squared is 15 squared. 30 times 15 is 450, minus 15 squared is 225. 450 minus 225 equals 225. So the two numbers that sum to 30 and whose product is a maximum are 15 and 15. Now we're going into the next problem and find the equation of the parabola through the points 0, 5, 213, and 326. We're going to assume that the equation has the form of this, which we would expect from a parabola. A point goes through 0, 5, and so in this case we know that x is, if we put this back into this equation here, 0, 5. X is 0, so we replace this with 0 and this with 0. We know that c equals 5. So because the y here is 5, so we put 5 here, and the x is 0. The x is 0, so these two terms sum to 0. So 5 equals c. So we know the value of c. Now we know that the equation has the form ax squared plus bx plus 5 because we found that c was equal to 5. Now we know another set of points besides the 0, 5, which we used over here, is 213. So we know x is 2, y is 13. So we go back into the equation, put the value 13 into this equation here, ax squared plus bx plus 5, and now we put 2 in because we know x is 2. Y is 13. When x is 2, So we're going to replace the x with the 2, and 2 squared is 4. Here we're going to get 2b, and we're going to get 5. So we get equation, when we transpose the 5 to this side over here, 13 minus 5, we get 8. This term gives us 4a, and this term gives us 2b. So we now have 4a plus 2b equals 8. Similarly, if we know that the parabola goes through 326. So when x is 3, y is 26. So again, we put this back into this equation over here. And right here, 26. So we put 26 here. And we get ax squared. If x is 3, this becomes 9 plus bx, 3 plus 5. So what we're doing here is putting the point 326 into this, and we get 26 equals 9a plus 3b plus 5. We transpose this to the left side. 26 minus 5 is 21. This is 9a, and this is 3b. So we have these two equations, 1 and 2. Put them together right here. 4a plus 2b equals 8. 9a plus 3b equals 21. And we're going to multiply equation 1 by minus 3 each term, so we get minus 12a. Multiply this by minus 3, we get minus 6b. We multiply the 8 by minus 3, we get minus 24. We're going to multiply equation 2 by 2, so we get 18a plus 6b equals 42. And the reason we do this is because the lowest common multiple here is 6. So we make 1 minus 6 and 1 plus 6 so that the b terms cancel. So we're eliminating the b term, so we only have a. So we have minus 12a plus 18a gives us 6a. Minus 6b plus 6b gives us 0. And minus 24 and 42 gives us 18. So we know that a is 3. Now we substitute a back into equation 1. So we get 4 times 3. 4a is 4 times 3 plus 2b equals 8. And we solve for b. So this is 12 plus 2b equals 8. 2b equals minus 4, b equals minus 2. So we now have c equals 5, a equals 3, and we had previously b equals minus 2, or here it is right here. We put that into the equation. The equation now is y equals 3x squared minus 2x plus 5. Now, to check this, we just choose one of the points, 326. So for y should be 26 when x is 3. So y is 26. We're going to take this equation here, the right side, and we're going to substitute x equals 3. So 3 times 3 squared minus 2 times 3 for the x plus 5. This is 9. 3 squared is 9 times 3 is 27, minus 6 plus 5, that is 32 minus 6, which is 26. So now the right side of the equation equals the left side, so that's a check. Now you could also go back and check with another set of points, 213 if you want. You don't have to just choose 326. You could put some other equation in there, and it should check out that that works. Okay, so let's go to the next problem. Here we're told that a football is kicked when it is 4 feet above the ground. 1 second later its height is 28 feet, and 2 seconds later its height is 20 feet. Assuming a parabolic flight for the path of the ball, express the height of the ball in a quadratic equation with time. So what we have is a ball. Let's say this is the ground here. Let's say the ground is here. Here's the ball 4 feet up, and it's kicked, it goes up, and then it comes down. So first thing we have to do, express the height of the ball in a quadratic equation with time x. So as we said, h is the time, h is the height, and x is the time. We've got to get an equation h equals ax squared plus bx plus c. We know that when x is 0, the height of the ball is 4, so that gives us c. Okay, so we know h equals ax squared plus bx plus c, because when we start off at 0 time, the ball is 4 feet high, and the only way it can be that if x is 0 and c is equal to 4. Now we know that 1 second later its flight is 28 feet, and 2 seconds it is 20 feet. So we're going to use that information. So let's use the 128, that's an ordered pair, and we're going to substitute it into this equation here. So 28 is the h value, okay, and a is 1. So x squared will be 1 squared times a is a, and here b, x is 1, so you'll just get b by itself plus 4. So we're substituting x equal to 1 and h equal to 28. So when you transpose the 4 to this side, you get 24 equals a plus b. So you now have, using the point 128, what the sum of a and b is. Now we're going to use the point 220. And don't forget, this information is obtained right here. So 1 second is my x, and 28 is my height. 2 seconds is another ordered pair, x value, and the height is 20. So we're using both those to determine what a and b are. 2 and 20. So we put that into the equation h equals ax squared plus bx plus c. H is 20, and we have ax squared. So a is, in this case, x is 2, 2 squared is 4, so we get 4a. bx, when x is 2, is 2b, and then we have c, which we know is plus 4. So from this we come out with, transpose the 4 to this side, 16 is equal to 4a plus 2b, which gives us 2. So now you can see that using using these points, we have been able to get 2 equations. And now what I'm going to do here is from equation 1, this one right here, I'm going to find that b is equal to 24 minus a. I just take this a and bring it over to this side, and I get 24 minus a. So I have b by itself. Now I'm going to substitute 4b in equation 2. So I get 16 equals 4a. 16 equals 4a. 4a is here. Now instead of 2b, I'm going to replace the b with 24 minus a. So instead of 2b here, I'm going to replace it with 24 minus 8, and here's the coefficient 8. So the reason I do that is I get everything in terms of a. I'm eliminating the the b term, so I can solve just for a. 16, 4a. 2 times 24 is 48. 2 times minus a is minus 2a. I'm going to transpose the minus 4a minus 2a is 2a. And so I'm going to have 4a minus 2a is 2a. And the 48 is going to go over here. 16 minus 48 is minus 32. So I have 2a equals minus 32 and a equals minus 16. Now I know that b is 24 minus a. So 24 minus minus 16 is 40. So I have a is equal to minus 16, b is equal to 40, c equal to 4 into this equation. Gives us the following. H equals minus 16x squared plus 40x plus 4. So this equation describes the parabolic path of the football once it's kicked. So B, when does the ball reach the maximum height? So it'll reach the maximum height because the graph is shaped like a frown. Along the axis of symmetry. So first of all, we need to calculate the time when it reaches the maximum height. This is minus b over 2a minus 40 because b is 40. 2a is minus 16. So we get minus 40 over minus 32, which is the same as 40 over 32, which becomes 1.25 seconds. This is the time when it reaches a maximum height. So the corresponding height at 1.25 seconds you get by putting 1.25 into this equation. So we put the one into the equation that we got here. So we put minus 16, 1.25 squared, plus 40 times 1.25 plus 4, minus 16 times 1.25 squared gives me minus 25. Okay, and 40 times 1.25 gives me plus 50, and I got the plus 4, and this works out to be 29 feet. So the maximum height is 29 feet. Now, the next part of the problem says, when will the ball hit the ground if it's not caught? So remember, what we're trying to do here is, here's the ball, here's the ground. Let's say this represents the ground. Here's the ball 4 feet up, comes down, goes on a trajectory, and goes down and hits the ground. So we're essentially trying to find when the height is 0. So what we do is set this equation equal to 0, and just to make it simpler, we divide through by 4, and what we get is 4 divided by 4 is 1, 40x divided by 4 gives us 10x, and minus 16x squared divided by 4 gives us this. So all I've done is rearrange this equation to this and then divide by 4. And then it's a matter of solving for x. There's no way you can factor this. No way you can factor this and simply. So when we can't factor, we use the quadratic equation. And here you see minus b is minus 10, plus or minus b squared is 10 squared minus 4a. A is the coefficient of x squared, which is minus 4, and c is 1 over 2 times a, which is minus 4. So when we do this, 10 squared comes out to be 100. This term comes out to be plus 16, and 2 times minus 4 is minus 8. Now we can only have a positive value. We cannot have a time that's negative. So what we do is, the only value, if we took the positive value, then we would get a negative time. So we only choose the negative 1 here instead of the plus. And we don't choose the plus one, we choose the negative one. Add 100 plus 16, take the square root, we get 10.77 minus 10 minus 10.77 over minus 8 gives us minus 20.77 over minus 8. So you can see a minus over minus is a positive, and the answer is 2.6 seconds. Okay, the last problem, 16b. Find the 2 points of intersection of the line and the parabola. Okay, so we have the equation of a straight line right here, and we have a parabola. So this straight line intersects the parabola in 2 positions, because we know that right here. So the point of intersection must be where the 2 y values are equal. So what we do is we set this y equal to that y, so that x squared minus 6x plus 8 equals x plus 2. Obviously, the only way we can solve this is to realize that if they intersect, the y values must be the same. That's going to give us an opportunity to get everything in terms of x. So now I bring this x to this side, I get minus 7x. I bring the plus 2 to this side, I get plus 6. Now I factor it, and I get x is equal to 6 and 1. When x is equal to 6, y is equal to x plus 2, 8. So that gives us one ordered pair. When x is equal to 1, y is equal to x plus 2, or 3. 1 plus 2 is 3. So the 2 points of intersection are 6, 8 and 1.1, 3. So those are the 2 points of intersection. To check, we substitute the value of x into both of these, and it should give the same result. When x is 6, y is equal to 6 squared minus 6 times 6, which is also 6 squared, plus 8. So these 2 terms cancel, and we get 8. When x is equal to 6 and we plug it into x plus 2, we get 8. So if it's a point of intersection, the x's and the y's have to be the same for both sets of points. The other point at which they intersect is x equal 1. If that's the case, we put 1 squared minus 6 times 1 plus 8, which is right over here, and that works out to be 9 minus 6, or 3. If we put it into the x plus 2 equation, we get 3. So that completes our discussion of